Hello, this is No Shot from RSA. Today, I'd like to cover the concept of log parser rules. It can be found in the UI under Configure, log parser rules. We're going to go through this interface and how to parse a log message. The documentation is on the following link. A lot of the details in here we're going to cover throughout this video. I will post this link in the video description. So what are the purpose of log parser rules? They were introduced in version 11.2. And the concept is simple, but we have to understand some guidelines around how a log parser rule interacts with a log message. The purpose of this tool is to parse log messages that you would otherwise not want to write a full-fledged log parser for through an XML or a Lua parser. That is, you just are looking for certain fragments of information within the log message that you would like to extract. However, there are certain guidelines that we must understand before we can write the rules. We have a concept in NetWitness of device type and message ID. When a header matches in a parser, that is, it understands that the pattern is more than likely this type of message, it will get a device type, RH Linux, WinEvent NIC for Windows, so on and so forth. And then further down in the true XML parsers that ship out of the box or ones that you may have customized, if there's a message definition, it will further break down that log message and parse the relevant or the constituent parts and put them into various meta keys of your choosing. And that is how a log gets parsed. There are certain use cases for using the log parser rules, but there are restrictions on how it operates and when it operates. So let's go through that. These are the two conditions upon which log parser rules can be used and cannot be used. If a message ID does not exist in either case, but a device type may or may not exist, that is, another parser within the system has decided that it knows this device type, but it cannot parse the message because there's no message definition, the log parser rules can be used to extract the contents of that log message into constituent parts and extract some metadata out of there. If the device type does not exist and the message ID does not exist, that is a net new event source and we have no concept of what it is, it does not match any pattern that we are aware of based on out-of-the-box parsers or parsers that you may have deployed, again, log parser rules can be used. The only time that log parser rules will not enact on a particular log message is when a message ID exists. So if you go into your environment and you happen to see a Windows or a Linux log or something, and it gets a message ID, this key, msg.id, the actual meta key is message ID. If it exists, that is, it's produced, this key actually has a value of something, then the log parser rules that you've defined here will not enact on that parser. You will have to customize the parser through other methods. So let's walk through the UI. Again, log parser rules can be found under Configure, log parser rules. On the left side here, we have the default parser. This is a parser that we deploy out of the box. It's on the file system, which we'll show later, and it has a handful of rules. So this is where we add our parsers. On the right side contain all of the rules for that parser. In the middle pane here is where we define our tokens, our regular expression, or some pattern based on what follows in that token, and then what key we're going to write to when we find a match. And down here is a sample area where you could paste in your sample logs so you can get a feel for how things are going to be interpreted and processed. So what you see is what you get. In the rules section here, I'm looking at our default parser out of the box. You should have this in your environment as well. We'll add a new parser here in this video. All of the pieces in orange mean that I have not selected it. I have not selected that key or that rule. But it shows that these pieces of information are in my sample log. The pieces in white, there is actually nothing here that matches those rules. So now let's click on one of those other rules. Destination domain. Notice that client domain was something I had selected, but there is no match for it. Destination domain. You could see here in light and dark blue for the selection I have of destination domain. Here are all the tokens. Again, out of the box, there's many of them because we know that a log message could have ad.domain.dest equals or dest domain colon space and so on and so forth. There's a variety of tokens that could follow a particular domain or destination domain. So we define the tokens here. And then, again, these are out of the box, they cannot be edited. So we just have a pattern internally, a match of host name. We'll do some regex later in our video. And then we're saying that when you match, put the entire string into domain.dest. And you can see that here is the pattern that matched, dest domain equals, and we do have a token here, dest domain equals right here. That's our token that it matched. And then the value of com is going to go into domain.dest. Similarly, if I go into username, because I know that it parsed over here because it's an orange, I can click on that and it will show me user equals and the tokens associated with the username parsing. And here's a regular expression for username. We know that the regex is a word, an underscore, a dot, an at, a minus sign. These are all character classes within regex, one or more instances of that. So it will follow and take as much of the data as possible given the word boundary, right? So that's why it's not taking up more. The concept of regex is beyond the scope of this video, but the regex that we support is Perl compliant, that is PCRE, Perl compliant regular expressions. So if you Google for PCRE, you'll be able to find the syntax that meets your needs. And then we have the concept of full capture, first capture, second capture, third capture. I'm not going to go too much into the details of this, but the full capture essentially means it's going to take the entire text. First capture means up to a certain delimiter, and we're going to actually do an example of this later. So if I were to change this full capture to user.source or just user, for example, then Matt would go into the user field, and Matt would also go into the user dest field. In this case, it's saying just match the strictest shortest case and don't match the rest of a string. In this case, there's no differentiation because this only matched a certain amount of text. We'll show in this video some differing things that come up as a result of using regular expressions and how the first, second, third, or even a full capture would be applicable. Now let's go through a scenario in my lab where I have a log message or an event source that is not parsing properly. My home network is comprised primarily of Ubiquiti Networks gear. I have logs coming into my log decoder from the provisioning server that manages my network. And I'm able to provision other hosts, change subnets, add new networks, so on and so forth. So that provisioning server sends syslog over to my log decoder. RSA currently does not support this event source. There are multiple ways to attack this. I can write a full XML parser or a Lua parser to handle that data, or I can take the route that I'm going to cover in this video tutorial. That is, use our log parser rules feature to do just that. Now, we're going to look at and compare the use case for this. So let's go to our investigate tab. And I'm going to look at the last 10 or 15 minutes of my data from my log hybrid. Get the network hybrid out of there. So you can see I have this IP, which is one of my access points, and it's showing up as unknown. Naturally, RSA has no support for this particular event source out of the box, and I have not written a customized one at all. So let's take a look at the log messages. If I double click on this and go to view meta, you can see it's largely word meta that gets parsed by default. We take a few characters of any log message that does not get parsed, especially unknowns, and we put into word meta to make it easier for people to identify certain pieces right out of the box without having to already build a parser. You can see the device type is unknown and there is no message ID. So in this particular case, I'm in this scenario that the device type does not exist. That is really aka unknown, right? Because we know device type of unknown is really no device type. And naturally, a message ID does not exist. So because these two do not exist, I'm able to use my log parser rules. If I had a message ID in here because it's got caught by some other parser, I would have to take a different route. So I'm good to go right now on parsing this particular log message. So let's go ahead and take a sample log. I'm going to go ahead and pick this log, for example. Let's just say we want to match this particular pattern. I'm going to go ahead and copy this log message. And I'm going to paste it in here. All right. So as we can see, nothing matches from the default parser. Even the destination MAC address. Notice the tokens here are DMAC, MAC, etc. There's expects to have some key value pair potentially. But in my case, the MAC address is just simply stuck in here in the event stream after the station or STA keyword, followed by the IEEE keyword, and is buried in here, for which we have no match. So I'm going to go and add a parser for parsing this particular log message. Let's go and add a parser. We're going to select new log parser. We can also extend a parser if we needed to. So as I mentioned, if you are in the scenario where you have a Windows message so that a device type exists, but the message ID does not exist, so you decide rather than going to the XML and customize the original Windows parser or make an augmented version of your own, we can use log parser rules. And this is why you can come in here and choose Windows, for example, WinEventNick, and the token file that gets created will be stored in that directory. And I'll show you a little bit later what that looks like. So we're going to go ahead and select new because I am not extending a parser. Device type, I'm going to put all in lowercase, Ubiquity Networks. The display name, I'm going to make it pretty, Ubiquity Networks. The device class can be so much, switch, a variety of things. I'm just going to choose router. Let's see if there's a network in here. No. Okay, so we're just going to choose router. Okay, it could be a router, switch, so on and so forth. And I can clone from the default parser. And now if I had a log message where a majority of the things match, but I just had a few more things I wanted to add for that particular parser, I could clone from those rules. But in this case, the default parser does not do much value for me, so there's no need to clutter up my tokenization by having those rules imported. So again, new parser, Ubiquity Networks with the display name, and I'm going to give it a device class, and I'm going to hit add. Now I'm left with this empty panel here, my sample log message, and a rule. Naturally, this is empty because I haven't added a rule yet. So let's say that we wanted to parse out the MAC address first. Now I know in my log message, the MAC address always comes after STA and some MAC address, particularly for message logs like this. So let's go ahead and add a rule, and we're going to call it MAC. And I'm going to say my token is STA and then a space. Notice that I have STA and then a space. Make sure you put the space in there because that is a literal, and you would get all kinds of parsing mismatches or no matches at all. So I'm putting the space in here. And then we're going to hit the plus sign. Having the token in there by itself does not actually add it to the list. You have to add it, and it allows us to add a new token. And we can keep adding as many tokens as we want. So if I get other log messages that have a different text followed by the MAC, I can come in here and add another token without having to redo my entire rule. Now I can come in here and write the regex pattern for our MAC address, but we have some already out of the box. So let's just choose MAC address. It's under the hood, already has the pattern matching for a MAC address. And then at least one meta capture must be required. So this is going to be a full capture because there's no delimiters. So I'm going to type in ETH, I'm going to type in MAC, and I'm going to see, okay, alias.mac is where I'm going to want to put it. Now look what happened. When I selected this key for this rule, first notice the red arrows here, circular arrows. That just means that this has not been deployed yet, but I'm going to go ahead and save it. Okay, so it's currently sitting on my head unit in a MongoDB configuration because this is persistent, but I've not deployed it to my decoder. When I do deploy, by the way, it will go to all of my decoders. So now I've got my token, and you can see here the light blue is my token. It's recognized. And in dark blue is the value that we put into alias.mac. So I'm going to go ahead and save that for now. Let's go ahead and put this text into something called event description. So I'm going to create a new rule, and I'm going to call it event description. I'm going to say a token would be 802.11 colon and a space, right? Again, I need the space in there because I know all my messages right after this keyword, I get the rest of it is a event description of what happened, disassociated, associated, failed, so on and so forth, any type of event that occurred. I'm going to go and add that token. Now notice that I'm selecting this particular rule that I'm working with, but the other one that has match is already in orange. It's a handy feature just to see how far along you have come in your parsing. Now, there is no typical text or any pattern that's going to be recognized for this event description, so I am going to have to make one. So I'm going to say that I want one or more words within this particular pattern match. And of course I could do full capture to get the entire text into my event description. And now there we go, right? So let's go and save that. Now you can see that I have 802.11 colon space, which is my delimiter. If I did not put that space, and if I did not put that space in, so for example, let's go ahead and delete this and put 802.11 colon and just add that. Save it. You can see that I got no match. I have to put the space in because the space is not a word boundary, so it's looking for any word boundaries right after that token, right? But I did not give it a strict match. Now I've got the MAC and event description both in orange. If I click on the MAC, I will see the rest of this in yellow, yellow and orange, showing me the counterparts of my actual selection. So we're going to save that. Let's go and add one more token because I want to pull out the process. Let's add a new rule, and we can call this process. And we're going to say that we're going to get a colon and a space that should match my process. I'm going to go and add in the token. I'm going to say that I'm going to get a word boundary followed by a colon, space, and then I know some interface is always going to be ATH6 or 1 or 2. These are Atheros chipsets, so I'm pretty comfortable with the fact that ATH will always follow my process ID. For this in a variety of logs, naturally there's going to be some small deviation in my logs, but I can come in here and continue to tweak and tune my rule set. Now I can do a full capture or first capture or second capture. I'll show you what the difference is here. So let's go to full capture and type in process. Let's go to first capture and also type in process. And we're going to show an example of what this actually is going to do. I'm going to go ahead and save that. We're going to come back here shortly and modify this after we look at it in investigation. And notice that I put the entire full capture of process in here, and I said first capture. Now, we're going to do spoiler alert here, but we're going to actually go validate this in investigation. The first capture means that any of my components within my regex, my first component here, that is particularly the host APD, and then I got a hard colon here, is going to be in process. But the full capture, that is the host APD colon ath, because remember this is my entire string match, the entire result of this, which is all of this data right here in dark blue, will also be in process, which is not my intended goal. So I will eventually deselect that, but I'm going to show you what that looks like. I'm going to go ahead and take a copy of this log message because I would like to inject this because my access points do not generate these messages too often. There isn't a whole lot of association and disassociations on my network, being a home network here. So I'm going to go ahead and inject the log to speed things up. All right, so notice we have this situation here with our two process is written to full capture and first capture. It is not the state we want to be in, but for the purposes of demoing, I will show you what the result is, and then we will look at it. So one of the things is I have not deployed this rule parser to my log hybrid. Let me show you an example. So if I log into my endpoint hybrid, which is effectively a log hybrid as well, under etc netwitness ng envision etc devices, you can see that I've got nothing here that's ubiquity, right? By the way, earlier when we chose a new parser, but if we could have extended it and we wrote these tokens, they would end up in the directory of the parser that already exists that you extended. So there'll be tokens, and the value of those token files is that they are yours and maintained by you. RSA does not take control of them. So when your live parser gets updated for Windows, Red Hat Linux, or what have you, then your token file sits in place, continue to operate on that data set, and so that we never overwrite it. So let's go and deploy our parser. I'm going to click deploy, and I'm going to say yes, deploy rules for log parser ubiquity networks to all log decoders. This is going to deploy to all of my log decoders in my environment. In my case, there's just the one. Now it's successfully deployed. So let's look at the log decoder. Notice I now have a ubiquity networks parser directory. And if I come in here, I have no message XML or INI file like you typically would see on, say, a Windows or any other parser, right? So if you come in here, these are the out-of-the-box XML parsers. Let's take a look at them. See the XML version, headers and messages and all this kind of stuff defined in here. If I go into my ubiquity, I just have my tokens. So let me cat that out. And you can see I have my string literals, my pattern matches, so on and so forth. And now this parser is actually active in my environment. If I go to admin, log decoder, view config, I've got a lot of things disabled here besides a few, but if I scroll up here, see now it's deployed, and anytime you deploy a net new parser, NetWitness will automatically enable it for you because the assumption is that you're doing it for a purpose. So now my ubiquity parser is enabled. Great. If I look at my log messages, I've got nothing in here right now, but I'm going to go ahead and inject the log message. So I'm going to make a test.log, and I'm going to go ahead and paste in my sample log message in this line. Right, so one log per line message, and I'm going to use the log player tool. You can install it. Yum search log player. There's the install for it. This is just a nice way to inject logs directly into your log decoder. without having to go into the UI to stop capture and load it manually. So let's go and inject the log message into my log decoder, and we're going to give it an IP parameter of 1.2.3.4, so it just shows up with the device IP that's simulated. This way I can differentiate between the live logs coming in and my test log that I'm actually working with. So now that record has been injected, we will go into investigate view and wait for that data to come in and do analysis. So now we're in investigate view with the last 10 minutes, and as you recall, I injected the log with the --IP of 1234 so I can easily find it. It will get stored under the meta key ip.adder, so make sure you put that into your meta group, and now you can see that I have 3 log messages that I've injected. However, when I pivot off of it, you can still see that it's still unknown. So why is it showing up as unknown when I specifically created a log parser rule for it? And I've actually deployed the parser, as we showed earlier. So a log parser is deployed. It matches my log message. Or rather, matches parts of my log message. So everything should be good. It is deployed as well. That's why there's no circular sign here. So the reason why it's not picking up as Ubiquiti networks is these log parser rules are very generic. I've only put tokens and expected patterns to match those tokens. There's no strict case for it to not match other types of log messages. And because regex and pattern matching can be costly, we at RSA don't want your system to be matching this across all of the log messages. That could be very taxing on your environment. Because you may only want to parse out these particular fragments from these specific logs and not everything. Because if this were to work by default on everything, not only would it be a performance impact, but it may generate a lot of log messages and parse things that you don't necessarily want parsed. So we need to do something specific here. So we're going to go into admin, and we have to map these event sources. So let's go into event sources and discovery, and notice that I have all these event sources, and I previously mapped them. That's why they showed up here, but for the most part, yours will show up as unknown. So I'm going to go ahead and map all of these. So under admin, event sources, in the discovery tab, I'm going to select all of my IPs. These are my Ubiquiti networks IPs. More than likely, these will never match from these 2 machines. That's usually these 2 that are at my access point, but I'm going to go ahead and map everything. And I click on map. And I'm going to type in Ubiquiti. The Ubiquiti network will come in. I'm going to add that to the mapping, and I'm going to hit save. That effectively does a parser mapping on my log decoder. So if I go to admin services log decoder, and I go to view config, and I go to my parser mappings tab, you can see that it maps these IPs. That is, anything that comes from this device.ip that has one of these IPs in it, it will match it directly against this parser. Again, we don't generalize when it comes to log parser rules. You must map it if you're in this scenario, that the device type doesn't exist and the message type doesn't exist. So in this particular scenario, we have to do the mapping. We'll talk about the second scenario later. Now let's go ahead and re-inject the log message. This time we'll give it a 1.2.3.5 to differentiate the message once again. Now that we've injected our log message, we can see here that we're getting some classification of my device type of Ubiquiti networks. So let's go and pivot into there. So these were live messages, so we're going to ignore the injection that we did earlier. We can see that Ubiquiti network shows up. Of the 4 sessions, they both have process of host APD and host APD :ath. So let's go and pull up this event. You can see here it looks very familiar to the one that our log message that we injected. So we're going to click in here, go to view meta, And we can see that it's a ubiquity network. Device class is router. Process was written twice. First host APD and then host APD with the auth. We'll come back to this in a moment. But notice that event description only has disassociated. It does not have disassociated due to inactivity, the entire string. So let's go and fix the two things. Let's go and fix the process, and let's fix the event description. We're going to go back into configure. Log parser rules, ubiquity networks. We're going to pull up our process. And as you recall, since we put a delimiter in here, but because we give the ability for delimiters to also, and the actual literals to also be part of the parse, because that may be your only delimiter that you can work with, but you also want that string in some message, or in some meta key, we allow that. But in this case, it's not a behavior that I want to see. So that's why my full capture, I'm going to go ahead and remove that. My first capture is all I want. The only word boundary that I see before the colon, right before the auth, for my Atheros chipset is all I want. So I'm going to go and paste in here. And you can see that even though it matches up to here, I should only get the process that is strictly this before the colon. So I will not get the full string because I chose it not to do a full capture. And if I had more regex, for example, ... I will be able to do that in my second capture and third capture and so on and so forth. Okay, so now I've saved that. I have not deployed this parser yet because I want to fix the event description. So notice that my original log had disassociated, but one of my newer logs has disassociated due to inactivity. So let's go and hard code that in here, due to inactivity. Now notice that I don't have any parsing for any text beyond that. Notice that none of my text after the first word parses into anything. That's why disassociated was the only thing that showed up in that meta key for event description. That's because I have a word boundary with one or more words. So rather than give it the word boundary, I went ahead and give it a dot star because I don't expect anything after this except for what I want to be an event description. Now typically dot star is going to consume everything, which is exactly what I intended here. But you may or may not want that, so just be aware and use this panel as your guide. I'm going to go ahead and save that, and I'm going to go ahead and deploy. Let's go ahead and re-inject some messages now. But before we do that, let's edit our text to add the rest of the text message so that we can see that the entire thing parsed. Okay, so again, it's a single line, even though it's word wrapped here, disassociated due to inactivity. So let's go and re-inject, but this time we're going to put 1.2.3.6. And potentially some live logs may be coming in that we can validate against as well. So let's take a look at investigation. Now we can see a log message here that happened to be the full text, so we know this is probably the one you want to look at just to see if things parse. So again, it looks like the log message that we're trying to handle, host APD, in this case is Atheros1, some station, was disassociated due to inactivity. You can see the service type is ubiquity networks and the service class is routers. It did parse. I'm going to go to view meta, and you can see this is a live log that came into my system. You can see now that there's only one process, one value for process. There's not multiple process listed here. There's no multiple values stored in that key, which is the intended behavior. We took away the full capture. Alias MAC is also populated. It's not indexed because that's the uniqueness. I'm never going to search on MAC addresses, so I just don't have it indexed. And now event description actually has the full string that we expected, and it still does our word meta parsing as well. So we've covered this one base case, that is the device the device type does not exist and the message ID does not exist. That was, we have an unknown message. If you have a known device type, because you already have headers or some log message that comes in that gets recognized as a Red Hat Linux log or Palo Alto Networks or what have you, but the message does not parse at all. Remember, if a message parses even partially, then the log parser rules do not enact, in this case here. But if you have, I'm not going to take us through this in this video, but if you have a scenario where the device type exists but the message ID does not exist, then you effectively follow the exact same rules that I've laid out, except under configure log parser rules, when you add a new parser, you would override, right? So you would say, I want to select this log parser. It would put the device type, it would put all the information for you already. You don't have to clone, you can add the parser, deploy it, and those token files would be under the Palo Alto Networks firewall and would parse out that log message for you. And the other beautiful thing about this particular scenario where you just want to pull fragments out of a message that has a known device type but an unknown message ID is you do not have to do the mappings because the headers already match in the existing parser. So we already know it's this type of device type. In my case, where I had no device type at all, I had to specify through the mapping functionality. So you will not have to map. That's one difference. And two, when you add the parser, instead of choosing new, just select the parser that you would like to augment. And the token files would be stored directly under that Etsy, NetWitness, NG, Envision, Etsy devices, and that device type you happen to be augmenting. So in addition to our out-of-the-box parser, you would also see a token file under here that would get reloaded and the decoder would operate on it. I hope this video was helpful. Please leave any comments or questions below.